trigonometric function. Okay. Let me first distinguish these two things: inverse versus reciprocal. Because of the notation, it's similar. It's going to trigger you mix these two things, and it's very important you don't mix these two things for this inverse trigonometric function. So reciprocal is the following. If I give you a number a, and then you can take a reciprocal like this, 1 over a. If a is 5 over 3, then 1 over a is 4 over 5, and the flip of that number. That is a simple algebraic thing you do for the reciprocal. Inverse is a lot more general. It's a more general idea than the reciprocal. It's more general. And one way to describe what this inverse thing is in general, more general, and it's a reverse of a process. And today, and it's very important for you to understand what process we're talking about here. So, like I said, reciprocal is a special case of inverse, and in general, inverse is not reciprocal. Okay? So, for the reciprocal, if you wanted to describe reciprocal as a reverse of a process, and what process reverse is this? Is the following. The process is multiplication by a. If the process is multiplying this number 5 to a given number, what is the reverse process? Is it dividing that given number by 5? Does that make sense? That is a reverse process. If I add 5 to a given number, what is the reverse process of that? It's subtracting 5 from that number. That's the reverse process. Okay? So if there is something, we do something to that, that's the process. The reverse process is undoing that thing, right? So what's going to happen to the input? If I have an input, I do a certain process and undo that process, and result to what happened to that input is untouched, so nothing happened, right? So that's the process we're talking about. So in general, it's more difficult. And today I'm going to introduce inverse trigonometry in this way to make sure that you understand what this one is. From there, you clearly distinguish this one from reciprocal of trigonometric functions. And once you understand all that, what you really have to do is fairly simple, but I don't want to do it that way. I want you to really understand what this inverse function is, because you're going to see this one forever until this whole calculus thing is over. And I don't want you to do that just mechanically. I want you to understand what this thing is. And so I'm going through a little lengthy discussion about what this inverse thing is. Okay? So here's the process that I was talking about. I'm about to describe the process. So here's the thing that we started with. That we thought about angle theta at the beginning of this semester. All right? Generalized angle, rotation, initial side and terminal side, all that. And then very recently, we did a lot of things to that angle theta and consider something called ratios. It's actually ratio. So I give you theta, and we did lots of things. Consider lots of ratio. Remember, consider ratio of hypotenuse and opposite. We consider ratio of y coordinate and x coordinate and things like that. Okay. So whatever happened in between, is I'm going to call process. All right. So here's one example of the process I'm describing here. I give you a theta, and we've been doing the following. We draw a circle, an xy plane. So circle of radius what? It's some arbitrary radius, any r, positive r. Could be 1, it could be 2, it could be 3. Draw a circle. And then we locate your angle there. Right? It could be several rotation and you ended up at that. And then we kind of label that terminal point with x comma y. So let me point out here, if I give you 147 degree, it is not something related to 30 degree and 60 degree and 45 degree, something an arbitrary angle. So let me claim that we can certainly think about 147 in here, and there is this position, whatever the radius you put it in there. We can certainly think about that there is this position, but there's no way to figure out and precisely what those values are, precisely what those x-coordinate and y-coordinates are, right? There's no notation other than sine and cosine, no notation to describe this one. We can only think about it, all right? So computability of this coordinate xy is gone. We can only think about it abstractly. So that's one part of the procedure. And then we considered this ratio called y over r. And that's it. That's the procedure. I give you theta. You draw a circle of your favorite size and locate that angle and get that y-coordinate of that terminal point and consider this ratio y over r. This is a procedure. Okay? And no human being has found a clean formula of this thing. This is input. All I want is this number. Is there quick and clean and nice way of doing that? No one has found out yet. Right? That's why we use a calculator. It always gives you some approximate value. But this process is still understood. And computing this x and y coordinate is not possible. So whenever this process is understood, mathematicians say it's defined. Whether you can compute it or not is the next question. So this is a process I'm talking about. This particular process I just described it here, has a name. It's a three-letter name. What is it? This process, I'm doing the whole thing, has a name. And you know that name. Three-letter. The answer is SIN. Sine. I give you theta, and then you put this one right in front of it like this, right? It's not like you're multiplying sin to the theta. It's not that. It is describing whole this procedure, and you wrote it down in your quiz solution, what we mean by the sine theta, right? So this entire procedure is summarized into three letters, sine theta, correct? And what is the sine theta? It's y over r. This simple statement in here, I broke it down like this. That's a process. What are we talking about here? Reversing this process, right? So that's what we're going to talk about today. All right. So if you look at all this one, do you see the difference? The reversing this process we're about to do is a whole lot more complicated than take the number and then flip it, right? It looks like a more complicated. And that's the inverse of sine function. We're going to reverse it. So I give you y over r, and we're going to think about theta. Okay? So let's reverse it. This one is, I give you an angle, you think about ratio. I give you a ratio, and we think about angle. So reverse process. And starting with an actual example, and that's much better. So I'm going to describe this reverse process with an example. Right. Given a ratio, y over r, given ratio actually 1 over 3, find theta. Okay. Does it look like a reverse? I give you this y over r thing, and you figure out what that theta is. And like I said, this is not going to be something you can actually compute by hand. But we're going to think about the process, of the reverse process, okay? All right. So here's the thing. First thing is what we're looking for is that this angle, all this procedure is y over r, right? So what this is really asking is that solve sine theta, that becomes 1/3 for angle theta. Isn't that summary of this reverse process? I give you a ratio and you figure out what the theta is. That's the nice algebraic summary of this reverse process. So here's how you're going to approach. Of course, I know my sine theta, which is y over r, and that's going to be my 1/3, right? So what are you going to say? y is going to be 1, r is going to be 3, right? Since r is supposed to be positive, there's no other choices. Let's see what kind of theta we're talking about. So I go here, always go to circle, and there's y-axis, and here's a circle, like that. Sorry about that. Try a little bit better. Okay, this has a radius what? 3. And we're looking for some points whose y-coordinate is 1, right? So here's also top of the 3, here's the 3 coordinates. So how many points do you see whose y-coordinate is a positive 1? Do you see points down here on the circle whose y-coordinate is 1? They're all negative, right? So it's up there. Which one is it? Is that points on the first quadrant or points on the second quadrant? Both of them have y-coordinate 1. Right? This is y-coordinate 1. So over here, do you see that point right here that has y-coordinate 1? Also here has one point that has y-coordinate 1. Correct? Yeah. So if I form an angle like this, that angle theta, you think that's going to be angle with a y-coordinate 1? So I don't know what that is, so I'm going to write it x1, 1. Is that correct? How about this guy over here? Y-coordinate is still 1, but x-coordinate is different, right? It's x2. Actually, let me just use x there, since you know better than just x1, x2. This is negative x, right? It's flip side exactly. So what is the angle for this one in here? The angle we're talking about is always start with the initial side, right? Where is our initial side for this standard angle? It starts here, right? And that's the angle. And also theta there. All right, what I just argued there are at least 2 angles for which the sine theta value is 1/3. Right? This angle, 1/3, and that angle right there, sine value is still 1/3. There are 2 angles. I claim there are actually more than 2 angles. Why is that? Actually, there are more. Because this is just a coterminal. I can go around like 100 times and arrive at here. That's a different angle, remember? Right, that's different angles. So there are infinitely many angles who arrive at here or arrive at there. But there are 2 destinations, in fact, 2 terminal points for that one. Does that make sense? Okay, so if you're reversing it, now we're facing the situation that when you try to reverse it, there are 2 answers. And you want to use a notation, and notation usually stands for just 1. So you have to make a choice here. So if you look at the calculator, there's a sine inverse button. That is a reverse process. And mathematicians decided to just stick to first quadrant. And if you have to figure out angle that is different first quadrant, you can figure it out by using the symmetry, and we will have some example. Yes? Right. This one has a different x-coordinate, but the y-coordinate is the same. When you calculate the sine, you don't care about x-coordinate. You only use the y-coordinate divided by the radius. So for these 2 points, they happen to have the same y-coordinate and the same radius. Therefore, the value is the same. That's why I was saying. So which one are we going to choose? And then the calculator decided to choose one in the first quadrant. Yeah? So what if I want an angle over here in the second quadrant? You have to figure it out, and you will have some example to figure that out. Okay? Does that make sense? All right, what if the y-coordinate, if the ratio is negative 1/3, and the angle is going to be down there, right? And then you also have to make a choice. We're going to use third quadrant and fourth quadrant. And they decided to choose fourth quadrant so that these 2 things are nicely connected. Okay? All right. So the theta, so to you, how does this theta look like? How many degrees to you? This is 40. Do you think it's slightly less than 30 degree if I sketch it like this? It seems slightly less than 30 degree. My guess, by just with this rough picture, the theta is roughly, I really don't know what this one is, 25 degree. My guess. It's slightly less than 30 degree. Seems like greater than 20 degree. But if you do this in amazing precision, then you can measure that with the projector with a very good angles, right? So although I failed to calculate this theta by hand, I think I described this reverse procedure very clearly. Once you understand this procedure itself, and we say it's defined. Okay? So we introduce this notation. I give you 1/3, and your reverse process is denoted by sine is reversed using the superscript -1. This is not a negative force power. Negative force power is called reciprocal, right? And this is not a reciprocal. And this is where the confusion begins to kick in. We actually do have a notation for the reciprocal of sine. What was that? Cosecant. Right. That's why they use different notation rather than this one. So whenever you see sine inverse, just assume that this is something complicated. Right? So we can only do it this way. So what is my guess here? Sine inverse of 1/3 is this angle theta I'm looking at in here. I'm roughly guessing 25 degree. All right, so let's read this one again. What this means is that if you hit the sine 25, it's supposed to be roughly 1/3, right? And your calculator has this sine inverse of 1/3. So I want you to have a calculator out, make sure it's in the degree mode, and find this sine inverse key and hit it and see what that really value is. And it is always approximate. So I'm going to always be using this approximate symbol, just letting you know that this is not something we can do easily. Calculator says is 19.4 degree. All right? So back then in ancient time, they created this table of sine and cosine, and you can just find where roughly 1/3 is and kind of backtrack your table and to get a rough idea of what the 19.4 degree is. All right? So that is called inverse of a sine. So try to reverse this process and all. And we're going to be doing it a couple more times in here. But let me say this thing in here. At this stage, at probably in session 3, we're going to learn a systematic way of, if I give you 19 degree, we're going to calculate that sine of 19 degrees. So how to come up with that table that ancient people did. We're going to understand the mechanism of getting that table without using anything but just, potentially the hand calc is tedious, but you can see that algorithm is doable so that you can actually do that by hand. So that's one thing we're going to do, and then that goes with a lot of some important and complicated formula. And then at the end of the Calc 2, and you're going to learn even more simple and systematic formula of doing that one. And I personally like that moment, and I feel like I have to play some Beethoven symphony to showing that formula of the sine, how you calculate the sine. Here is a formula. That formula is something even my son can understand what to do to calculate a sine, because it's that simple and beautiful. So that's the end of the sine calculus 2. All right? But we're going to do something also in this course to get this, how to calculate sine 19. How is this calculator got all this value? They didn't really measure it. You can actually have, pencil and paper, you can get this down to an arbitrary precision. All right. So, I was talking about right now. I was talking about this process. The, forward process thing is very difficult, and there's no clean formula. Hence the name of a transcendental function. The sine function, cosine function, these are called the transcendental function. The values of this thing, it is beyond our reach to compute it precisely. Not to mention reverse the precision. All right. So here is some important statement. This is something you really need to memorize. Sine of what goes in the sine inverse? Sine inverse is reversing, is the ratio goes in there, right? You happen to know the ratio, right? And calculator will tell you approximate angle of this theta. But we can certainly think about the exact value, you just don't know what that is. Alright? When you do that, how many angles are there? How many is angles for the sine theta that gives you y over r? There are many, many angles here, right? But we can always choose an angle that is in the first quadrant and that is in the fourth quadrant. So how do you describe it in terms of measure of the angle? If it is in the first quadrant and the fourth quadrant, what is the smallest degree you see in there? Is negative 90 okay? That one down here is negative 90 going backwards, right? And going forward is a positive 90 degree. Alright, what that says is that if you use a calculator and sine inverse of whatever y over r you plug it in there, the calculator will only give you an angle that is in between negative 90 degree and positive 90 degree. But I was saying there are actually angles over there in the second and third quadrant, but because of the symmetry of a circle, you can figure it out. But what you're going to get from a calculator is not the full solution of this equation in here. To reverse it, they have to make a choice. It's called branch cut. So let me do the second thing. So how are we going to remember this this range? And this range is very important. Every time I do this problem today, I'm just keep writing down this range so that you remember that is something attached to this idea of the sine inverse. Okay. All right. So here's why. If you go through this angle in the first quadrant and the second quadrant, you can see y coordinates keeps changing. And down here, y coordinate changes to negative number as well. So as I go over angles from the first quadrant to the fourth quadrant continuously like that, is there ever the y coordinate repeats? R is always fixed, right? Radius never changes. Y coordinate from a positive r to negative r never repeats, right? So there's a unique correspondence with the angle and y over r. So that's why they chose like this. What if I go over the angle from here to the second quadrant? Do you see this y coordinate repeats here? That y coordinate repeat there. So there are two angles. So it's not good. So that's why they chose like this. The region where the y value doesn't repeat. Okay? So this is reverse of a cosine. Cosine has a ratio like what? X over r, right? I give you ratio, and you think about the angle, and use a calculator to get that approximate value of theta. That's the idea. All right? Now, what about this angle theta here? Let's go over exactly the same thing. Cosine is connected to what? X coordinates, right? So if I started here 90, go all the way to negative 90, do you think the x coordinate never repeats or repeats? Here x coordinate is 0, right? Here x coordinate is like half of r, and here is x coordinate r. How about here? Like half of r, and here's 0, right? So did x coordinate repeat it? It repeated, right? So if you range through like this, and you're going to have two angles giving the same x coordinate, so it's not unique. So they decided to go different range. Of course, we're going to keep that first quadrant, and if you go over to the second quadrant like this, you see x coordinate here is r, x coordinate 0, x coordinate to negative r, right? You see that x coordinate never repeated. So they decided to choose this range of angle where cosine value and the angle is the exact one-to-one correspondence. So what is the angle here? Lowest angle? 0, right? Go all the way up to where? All the way up to here. What is that angle? 180 degree. Okay? So if you hit cosine inverse, and all you're going to get from a calculator is angle between 0 and 180. But if you're looking for a different angle down there, then you have to flip it and add and subtract a little bit to figure that out. All right. What's the third one? Tangent, right? How does the tangent look like? Y over x, right? So y over reversing it. I give you y over x. You think about the angle that gives you y over x. Okay? So what is the next thing we figured out? Range for theta, correct? Yeah. This time it's not just y over x, it's just ratio of y over x. If angle ranges from 0 to 90 degree, we have certain ratio, all positive. How about 90 degree to 180 degree? Will those ratio remain positive or negative between 90 degree and 180 degree? Y over x. Y is always positive here, x is negative. So the ratio will be negative, right? So positive and negative, isn't that what we're looking for all the time? So it seems like the answer is just 0 to 180 degree. But just for fun, we're going to do the other one too. This is all positive ratio. What about down here? Isn't that also positive ratio? Yes, for x, but for y is a negative. So we get a negative ratio. So from 0 to 180 degree, you never get a repeated ratio. From 90 degree to the negative 90 degree, you also get a non-repeated ratio. And actually they chose 90 degree to negative 90 degree. And here's why. At angle 90 degree, what is the x-coordinate? 0, right? X-coordinate is a 0. What is the tangent value of the 90 degree if x-coordinate is 0? Y over x, right? Y is r and x is 0. So what is r divided by 0? Undefined. If the 0 goes to the denominator, it's undefined. You don't want to go through like that and all of a sudden in the middle there's undefined, right? So they decided to go the other way. And what about the angle right here? What is the x-coordinate there? R, right? What about y-coordinate here? 0. So 0 divided by r is actually 0. So that's defined. So they want this nice range. There's no break in terms of the value. So they decided to choose negative 90 to positive 90. It covers all the ratios without repeat in that range. So when you think about when you use this sine inverse, there's this theta attached to it. What you're going to get out of the sine inverse symbol and cosine inverse symbol, tangent inverse symbol is limited, and you have to use the symmetry to get all the possibility out. All right, so I want you to go ahead and box this one and kind of show off your knowledge in calculus when you get there, and in this course. All right, you boxed it. So let me do some problems to get used to this. Right, this is a problem. Is about more about the process. It's not about getting the value. Okay? So I want you to draw a circle and pay attention to the process the way I do it, and it's going to show me that you understand what this inverse function is about, not that you can use a calculator to get the values. Yes. I'm going to phrase exactly the same way. Use the circle definition to do this problem, and then you have to show the process I'm about to do. Okay? All right, so here's part A, and you first write this one down. Sine inverse of root 3 over 2. Copy that problem exactly. Okay? Then you recognize this is a reverse process, right? So this is supposed to be the ratio, and you're supposed to figure out the angle, opposite way. So I'm going to call that one, entire thing, theta, the angle that we are looking for. Okay? Rather than just, what am I going to do with that root 3 over 2? Some algebraic procedure, I want to get theta. That's not what I'm doing. I'm just labeling this theta and doing some algebra on top of this notation theta. And I think this little thing, the naming thing, makes a big difference in terms of how you manipulate things. That's why I put it in red color. I want you to pay attention. This one little thing that you put it in there give you a whole lot more power to manipulate this one. Okay. And then next thing you do is that whenever you're dealing with the sine inverse, there's this inequality, right? This generic inequality that comes with it. Well, what is this for the sine inverse? The principle was that what is the range of this angle where sine ratio does not repeat, where y coordinate divided by does not repeat? Negative 90 and 90. That is fourth quadrant to the first quadrant, y coordinates changing sign, not repeating. Does that make sense? All right. Whatever the theta is, it's guaranteed that it's falling between and here. It is not really a specific result about this root 3 over 2. You always have that tagged into sine inverse calculation. Okay? When I was introducing this reverse process, I said the following. This is supposed to be the angle whose sine value is root 3 over 2. So algebraically is really this. Sine theta is root 3 over 2. Isn't that right? We're looking for that angle theta whose forward process gives you the ratio root 3 over 2. Correct? Yeah. That was the algebraic formulation of our reverse process right here. Okay, give you the ratio. You actually wanted to figure out this theta. So what I did with 1 and 3 is I wrote y over r there, right? So what is y? Root 3. What is r? It's 2, just like I did with 1/3. Then next thing I did is I go into circle. This time, I don't have to think about which quadrant and all that thing. Theta is in where? First and fourth quadrant. We already know that. Okay? So here is a circle. And radius is what? 2. And y coordinate is root 3. And that is not over here. Always in the first quadrant or the fourth quadrant. So I think root 2 is close to 2. So I will put it over here. That is where y coordinate is root 3. So that's the angle we're talking about. That angle right there. In between negative 90 and 90. Does that make sense? And they want us to figure this one out. And we're doing that without using a calculator. Okay. So what can you do? That usual thing we do here is this triangle. Remember this triangle? Right triangle you can put down. So I'm going to resketch the triangle over here, there, and there. And that's the theta we're looking for. And I know this hypotenuse. What's the hypotenuse of this right triangle? 2, right? That's the radius right here. Is that right? That makes sense? Yes. How about the height of this triangle here? Root 3, that y coordinate is the height of this triangle. And what is the remaining side here that we don't know? 1, because you remember this guy, right? 1 root 2, right triangle. So what is theta? 60 degree. It's a miracle. That is just popped in at 60 degrees. So there is this root 3 over 2, and then reverse process give us 60 degree. Is that right? So how did you discover the 60 degree? What would be the word that describes your method of finding the 60 degree? You draw the circle, but at the last stage, somebody said 60 degree because you just remember this thing, right? So I will say search. You searched your database, if you think about it that way. It happened to be in your database, right? 60, you know that's the only angle it does it. Right? That's what I'm talking about, that table. You just go through and find out where they are. And that's what we just did. So in general, you can see that there's no way you can actually do this other than searching. All right. So let me write down the answer in here. Answer is that they ask you to compute sine inverse of root 3 over 2. Then answer is theta, and the theta is exactly 60 degree. That's your answer. You write down the answer like this. And after you write down the answer, you interpret it, make sense out of it like this. Sine of 60 degree is root 3 over 2. That's what that means, right? And you know that's true. Is that right? All right. So I want you to take out your calculator and hit sine inverse root 3 divided by 2. And if it is in a degree mode, it should spit out 60 for you. So the sine inverse thing, this inverse of this thing represent angle for which The sine value is that given ratio. Any question about this one? Doing like this only works for an angle that involves a special ratio, right? So I'd like to make this part B an exercise. You just repeat this process. I bet you can do this. So I'm going to hide this one and just write it here. Is exercise. Compute a cosine inverse of negative 1/2. That's what it says there. That's your exercise. Okay, I got down here the second quadrant. Is that right? X is -1 and radius is always +2. So I locate that point roughly there. And then I draw this triangle, and size is again the familiar one, 1√3. So the angle down there is a 60 degree. And I wrote here, answer is not 60 degree. Theta is not 60 degree. Theta is the remaining angle, remember? That is the angle for that terminal point. Okay? So how do you compute theta? 180 minus 60, is that right? Yeah, so 120. The 120 angle over there will give you x coordinate -1. Okay, so let's write down the answer. How does the answer look like? Cosine inverse of -1/2 is exactly 120 degree. So if you don't believe it, cosine inverse of -1/2 in your calculator, and it'll give you 120 exactly. Okay? So calculator will verify your answer. Exercise is computing tangent inverse of 1. Right? I don't want you to just go through all the special triangle and figure it out. I want you to do this circle, right? You have to use the circle method. I think it's a good exercise set to make you go back to circle once again. Earlier, remember I said that it is not defined at the 90 degree, so you can't allow that theta is 90 degrees. So this one is a special shape. Here's less than. Theta cannot be, it's not defined at 90 degree. So you have to get rid of this equal symbol to strictly less than, strictly less than. I apologize about the mistake. And down here, that's what you're going to copy down here, right? -90 degree, strictly greater than, and strictly less than +90 degree. All right, how was it? Got 1 for x and y coordinate, and it creates 45-degree triangle in the first quadrant. And you know that angle down there is really the theta, unlike the cosine case. And we know it's 45 degree, right? Okay. Any question about these examples? Yes. So here's a new set. And for this one, it's not going to be exact. I can tell you that. So we're basically going to rely on a calculator. But I will still try this one on the circle, and so that in here with me that you experience a little bit more about this reversing process. And I already forgot what the answer was, so it's going to be fun. So it's part A. All right, sine inverse was of -0.71, right? When you look at it, always you continue to what statement? Don't just write it like this. Equals theta. Always write it like that, right? And what do you think about next? Theta is in between -90 degree can be equal to +90 degree. This is generic result about sine inverse, right? And then next thing is that, all right, what is it? Sine theta is supposed to be what value? Y over r. Here is a 0.71, which is supposed to be y over r. That's right. Okay? Make sense? So what is going to be y and what is going to be r? R be 1 and y will be 0.71. Is that all right? That'll work. Or guy like me will think about, I want 71 divided by 100. then y is going to be 71 and r is going to be 100, right? But this is simple enough. So I'm going to stick to this one. So what is the next one? Go to circle. What is the radius of this circle? 1. That circle has name. It's called unicircle. Unicircle in there. So y coordinate is a 0.71, right? So this is 0.5, agree? 0.5. This is roughly 0.75. So I think it's somewhere down here. Would you agree that that's roughly where 0.71 is? And then angle is going to be in first quadrant or fourth quadrant. It must be over here. That angle right there. All right? So let's go for it like that. That's the angle theta we're looking for in there. X comma 0.71. Agree? So if you believe I kind of sketched it carefully, what kind of angle do you see? What did you estimate by just staring at this picture? 45-ish. I'll go for 45-ish. Would you agree that looks a lot like 45, right? So here's moment of truth. Let's hit it. Sine inverse of 0.71. In fact, what is it? It's close to 45, isn't it? Yeah, close to 45. 45 point what? What is the first two? Yeah, somewhere there. All right. What is sine 45 then? Anybody remember sine 45? 45 is a special angle. Right, so 1 over root 2. Isn't that sine 45? 1 root 2? So what is the value of 1 over divided by root 2 decimal? 0.70, something like that. So you see that's a similar. That's why. 45 degree has this value, and you chose a value that is very close to that, and then you pick up 45, close to 45. Does this exercise make sense? Alright, so part B is your exercise, and you can just hit it with a calculator and get an answer. Just for fun, I want you to just draw this circle and estimate first before you hit a calculator, right? Draw it carefully, estimate it, and see if your estimate is close to the answer. So here's exercise. Do this without using calculator. Maybe that's the instruction. Alright, was that okay? When I sketched it carefully, it looked a lot like a 60 degree to me. So, but the actual angle is a 63.4. I'd like to make this one exercise. I know you can do it, so we're going to do it. Here, you don't have to go to circle. Right? This is more about just calculating, right? So you don't have to go to circle or anything. Just use your calculator and whatever is necessary. Just figure out what that angle theta is and a rather more precise value. Was that all right? I considered sine because that's what theta and the other two sides are related. So I looked at this equation. Sine theta is 10 divided by 50. It is 1/5. So that's the question in here. Sine theta is 1/5. That's a reverse question, right? I give you the ratio and we're supposed to figure out the theta. So that's, all right, if I have a ratio, what is this angle? And that's the meaning of sine theta, sine inverse. All right? And that's always in between 90 and negative 90. So here's the second one. This requires sketching a little bit, but it's basically the same thing. So hope you be able to sketch a picture and complete the problem. Right, this is also an exercise. Alright, I think that identifying theta in the correct position is one tricky part. Right. And I also put here is slightly different. This is just recognizing theta we're looking for is in between 0 and 90 degree. So when you use the sine inverse, it'll give you negative 90, 90, right? So that's good enough. That's the meaning of this range in there. All right. So here's a new set of problems which I'm going to do with you. A. Find an angle in between 0 and 180 degree. Okay? That's what they're asking for. There's no sine inverse. And we want to solve this equation. So I'm going to write it down. Part A, sine theta is 0.4. Okay? So this is reverse question. They gave you the ratio and asking for the angle. So what do we do here? We consider sine inverse, right? Of 0.4. And I'm going to calculate that angle. Can somebody do this for me? Sine inverse of 0.04. I mean 0.4. So let's say it's a 23 degree. Is that right? Yeah, that's a 23 degree. So here's one thing. They're looking for angle 0 and 180, not just negative 90 to positive 90. So theta being roughly 23 degree is one solution. Find all the angles. Maybe there's more than one angles. That's what they're suggesting. Okay? So I'm going to draw it like this. 23. So where's 23? Is roughly over here. So about the last one. Slowly. So this is a radius. You can think of it as 0.4 as y divided by r, where y is 0.4 and r equals 1. Is that okay? Sine theta being 0.4. So here's r equals 1. And radius, the y coordinate is a 0.4. This is roughly 0.5. So I think this over here. That's the y coordinate being 0.4. And that looks a lot like close to 30 degree, if it is more accurate. So that's where the 23 is. And do you see in between 0 and 180 degree, there's one more point whose y coordinate is exactly 0.4? You see that? Between 0 and 180 degrees. It's over here. Correct? That one also has y equals 0.4. X coordinate is opposite sign. So what is the angle for that guy? Right, it's going all over that angle. That's the theta. That's another possibility if you go outside negative 90 to positive 90. Does that make sense? Yeah. So another possibility from that picture is a theta being 180 minus that angle right there, right? That is the same angle as the calculator gave you, 23. So it's 23 subtracted, and what do you get? 157, right? If you don't believe it, and you go in sine of 157, you type it in, and you're supposed to get 0.4 back, right? So here's the verification. If you want to verify your answer is correct, go ahead and evaluate sine of 57. That is supposed to be a number close to 0.4. Okay, with your calculator. One thing that I didn't mention it here is that I want you to go ahead and type in cosine inverse of 2 and see what you get. We did tangent inverse. I skipped that cosine inverse of 2. So what do you get in the calculator? Error message. Let's make sense out of that. What is the angle for which the ratio y over r, x over r, is 2? That's what we're looking for, right? Remember, x coordinate on the circle cannot be more than r or less than negative r. It's trapped in that circle, right? So you will never get x is 2 times the ratio, the radius. That's what that means, right? X equals 2 times the radius. This will never happen on the circle. So this is not the ratio you can achieve any angle. Therefore, it's undefined. Okay? So for sine and cosine inverse, if it is more than 1 or less than negative 1, you will get an error message. And don't panic. That means that there's no such angle theta. Okay? All right. I had to do one more thing, unfortunately, so forgive me on that one. So this example, this one is supposed to be exact. So we're going to do this one without calculator. If you do this one with a calculator, then you will get a decimal number. If you type that into whatever sign, you're not going to get a full credit. Maybe 0 credit for that. So here's some bulky notation. That's the tricky part. Let me write it. Cosine of sine inverse of 3 over 5. So we're doing inverse procedure and forward procedure of a different type of trigonometric function. Okay? So what is this one? And that's what we're calculating. And you're not going to type cosine of sine inverse of 3 over 5 in a calculator. Not that. We're going to do completely by hand. So key thing is that letting this inside be represented by theta, and it gives a lot more power to handle this guy. That's the first step. Sine inverse of 3 over 5 led to theta. What do you put it here? Always sine inverse, negative 90 to positive 90. Then sine theta is, I had a difficult time to get this one right next different class. If sine inverse of 3 over 5 is theta, what is sine theta? 3 over 5. That's the meaning of sine inverse, right? Okay, so from there I can get everything about the theta. So here, this is y over r, correct? So what is y? 3 and r here is 5. And going to circle. And which quadrant is this? First quadrant. So here's radius 5. Y coordinate 3 is somewhere here, I guess. 3.5, somewhere a little low, I think, over here. That's the y coordinate 3 and x coordinate, don't know. How do you calculate x coordinate? X squared plus y squared is r squared, right? So it's 5 squared. So x squared is 16. So x is plus minus 4. Because we know it's in the first quadrant, x is a positive 4. Okay? So there is a theta I introduced. There's no theta in the problem. I introduced theta inside the angle in here. And have a pretty good information about the theta. Let's go back to the original problem. The original problem is a cosine of sine of inverse of 3 over 5. That's the original problem, right? And we have a notation for the inside bulk. Sine inverse of 3 over 5. What is the notation for that? The whole thing is called the theta. Remember? The whole thing is called theta here. It's magic. What is cosine theta is here. That is sketched over here, right? We know the sine theta. I sketched everything about the theta in here. So what is the cosine theta here in this theta description? X coordinate, right? Divided by radius. What is x coordinate? Here is 4, right? So 4 over 5. So final answer, cosine of sine inverse of 3 over 5 is 4 over 5. I didn't use a calculator, but you can verify it, right? Sometimes this number will involve the square root of nasty value. Then by doing that with a calculator, we'll never get the square root value correct. Here we're lucky, everything is whole number. So whatever sign is probably going to use the square root, and you have to use that exact square root value to take that. So this is I thought it's a good exercise, makes you think about whole inverse process and going to circle and all that, rather than just using the calculator. Sorry about going too long.